Hi, today we'll be multiplying and factoring polynomials. But let's start with something that we're familiar with. So 12 times 11 is 132. But I could break up 12 as 10 plus 2, and I could break up 11 as 10 plus 1. Let's multiply 12 times 11 using an area model. So just like a multiplication chart, if I want to multiply 3 times 4, I would just line up the 3 and the 4, and 3 times 4 makes 12. So I'm going to do the same thing in this area model here. So a 10 and a 2, I'm going to put the 10 in the tens place and the 2 in the ones place, and the 10 and the 1 up on the top. So I'm just going to do the same thing as I would do over here in a multiplication chart, and I would do 10 times 10 makes 100. And 10 times 1 makes 10, and 2 times 10 makes 20, and 2 times 1 is 2. All right, so I have, using my area model, 100. I have 10 and a 20. I'm going to combine those because 10 and 20 make 30. I have a 3 in the tens place, and finally a 2. All right, so let's apply that method when multiplying binomials. So this is a binomial, and we're going to multiply two binomials to make a trinomial. All right, so x and 4, I'm going to put here, and x and 3, I'm going to put here. X times x is actually, if we're going back to algebra tiles, x times x is x squared. So I have 1x squared when I multiply x times x. X times 3 is 3x, so I'm going to put 3 x's over here. 4 times x is 4x. 4 more x's, and finally 4 times 3 is 12. I don't want to write out 12 pluses, so I'm just going to put 12 units. What's inside of my table and write it as my answer. So I have 1x squared. I have 4 x's and 3 x's, just like I wrote out here. I have a combination of 7 x's and then 12 positives. So what I did here was I combined to make 7 x's. I think I'm going to skip over the next one, and let's go in reverse. So this time I have my trinomial, or my product, and I need to find the factors that make up that product. So just as before, I'm going to use the same thing I did up here. I'm going to fill out my box and then find what makes up the terms inside of this box. All right, so I have an x squared. I knew that was here, and the way we got x squared was x times x. I had to come up with these two numbers, right? Those I was combining. So let's skip over that for a second, and let's go to put the 9 here. So notice up here that 4 and 3 made 7, combined to make 7. But check this out, 4 times 3 also makes 12. That's not a coincidence. That's where actually I'm going to get these two numbers here. I'm going to get it from this 9 over here because I know they have to multiply to make 9. So I have a 9. The first factors that come to mind are 3 and 3. But if I put 3 and 3 in these boxes, they're not going to combine to make 10. So another factorization of 9 is 1 times 9. That, in fact, is going to work. 1 and 9 do make 10. So they should combine to make 10. So I have 1x and 9x. All right, so now I just have to figure out the rest of the outside of my box. What times x makes 1x? 1. And x times what makes 9x? 9. So my factors are x plus 1 and x plus 9. Let's go back to multiplication again. Let's multiply these binomials. This time I don't have an x and an x, I have a 2x and an x. So I'm going to put 2x in 1 and x in 3. So I'm going to start filling out my box. 2x times x is not just x squared, right? It's double that. I'm going to have 2x squareds. And then 2x's times 3 is not just x times 3, but double that. So 6x. 6x's. And 1 times x is 1x. Add another x there. And then 1 times 3 is 3. Right? I have 3 here. So let's list the results of our multiplication table. I have a 2x squared. I have a combination of 1x and 6x's, just like over here. So I have a total of 7x's, and I have 3 positives. So notice that 1 and 6 make 7, but check this out. 1 and 6, 1 times 6 is not 3. But remember, we didn't just say x times 3, we said double it. We doubled it. So this time I'm going to have to, if I were to go in reverse, I would have to double 2 times 3, which is 6, and then 1 times 6, and 2 times 3 are the factorizations, and 1 and 6 combine to make 7, which is exactly what we used. So let's try that going in reverse here. So I have 2x squareds. I have 8 ones. And now I've got to figure out what I'm gonna combine to make 10x. But then when I multiply, it's gonna be double 8. So it'll be 16. So if I double my 8, I get 16. The factors of 16 are 1 and 16, 2 and 8, 4 and 4. In order to get 10 x's, I need to use the 2 and the 8. So 2x and 8x combine to make 10x. So instead of it being just an x and an x, it's going to be 2 x's, just like above. All right, so 2x times what makes 8x? 4. And what times x makes 2x? 2. And the way we check it is 2 times 4 makes 8, so we know we're all good. So my factors are 2x plus 2 and x plus 4. Another way I could have done that is what factor do 2x and 8 have in common? They both have a factor of 2. What factors do 2x squared and 8x have in common? They both have an x, which is there, and they both have a 2, because 2 times 4 is 8. So I could have done it that way too. All right, but what if some of you may have been saying, well, how did you know where to put the 2 and the 8? So let's see here. Let me rewrite this. What if I would have put the 2x here and the 8x here? So I have a 2x and an x. What do these two have in common? What factor do they have in common? They both have an 8. Or I could have said what times x makes 8x. And 2x times what makes 2x? I just need a 1. So 2x plus 8 times x plus 1. Is that statement equivalent to 2x plus 2 and x plus 4, like we got before up here? Well, I see that 2x and 2 have a common factor at 2. And I see that 2x and 8 also have a common factor at 2. So now they're equivalent. And I actually like it in this form better because the whole point of factoring is to find zeros of a quadratic equation. So this way I found my zeros, and the 2 is actually my stretch. I think I'm going to move on to more of a challenge. I had these problems for you, but I want to keep this a little bit shorter, and I only have about another minute or so. So let's do this one. All right, so I have 6x squared, and I have -2. So I need to figure out what I'm going to put in these two boxes here. So I have actually not a -2, but 6 times -2, which is -12. So the factors of 12 are 1 and 12. I'm putting them kind of separate because I know I'm going to have a negative sign in there at some point. 2 and 6, and 3 and 4. All right, so whatever ones I use have to add up to just 1x. Well, none of them are going to add up to just 1x. I've got to have some negatives in there. So which one of these, if I made one of them negative, would end up with 1x? They're just 1 apart. So these aren't 1 apart. These are 11 apart. These are 4 apart. These are 1 apart. There's only 1 in between 4 and 3. So I know that if I made a 4 positive and a 3 negative, and I added those together, well, that's multiplying, makes -12 is what we have up there. But if I put those together, we'll put a little adding sign here, I would get a positive 1x. So those are the two I'm going to use. I'm going to use the -3x and a positive 4x. All right, my next problem is, remember, it's not x times x, it's going to be something times something makes 6. But I've got two options. I could do 1x and 6 x's, or I could do 2 x's and 3 x's. So I don't know that yet. So I need to start, I've kind of got to like investigate the inside of the box. I'm going to start down here. All right, so what do 3x and 2 have in common? They don't have anything in common. They do have a -1 in common, though. They both have a -1. All right, so that being said, -1 times what makes -3x? I just need an x, right? Because 3 x's, because 3x times -1 is -3x. All righty. So that was enough to give me the 6x squared. Now that I know that this is 3x, I know this must be 2x, because 2 times 3 makes 6. And now that I have this 2, I know that 2 times what makes 4x? 2. And here's our final check. -1 times 2 makes -2. So I know my factors are 2x minus 1 and 3x plus 2. So hopefully that's helpful for a review of factoring and multiplying polynomials.